Okay, so the today lecture topic is the giant probability distribution. So we have already covered discrete probability distribution, continuous probability distribution, different discrete probability distribution, just like Poisson distribution, binomial distribution, negative binomial distribution, hypergeometric distribution, uniform distribution, normal distribution. And now you people also know how to use these type of distribution, where you will use it. So I have already mentioned different indicator of these distribution where you will be able to use this. So now, in order to further extend the concept of probability distribution, I'm just going to start giant probability distribution. So giant probability distribution means there will be now two type of random variable. Before we have only consider one type of variable. Let's suppose x is a random variable. When we throw a coin, when we throw a die, let x represent the number of head, x represent the number of event. Now we will consider two type of random variable, and at the same time we will handle those two type of random variable. So that is why it is called giant probability distribution. That means there will be a combination, there will be a giant probabilities. So distribution. So let x and y be two discrete random variable defined on the sample space S of an experiment. The giant probability mass function, before we denote the giant probability mass function, or it is also called probability distribution function, so we just denote this with probability of x or probability of y, because at that time we have only one type of random variable. But now this will be the combination, this will be the venture of giant. So that is why this is called giant probability distribution. The giant probability mass function we will now denote, instead of this we will denote it with probability of x and y, because we have now two type of variable, one is x and one is y, is defined for each pair of number x, y. And we will write this like this way, probability of x comma y. So x will be related to the random variable, the event which occurred in x, and y will be the event which occurred in the y. It must be the case of that pxy will be greater than or equal to 0, and when you sum it, it will be equal to 1. So you remember, in the single probability distribution, we always consider that probability of x will always be greater than or equal to 0, because the total probability is equal to 1, and the values of this may be between 0 and 1, but it will be equal to 0, it will never ever be less than 0. Similarly, for the giant, it will be greater than or equal to 0. And you remember, we have already solved different problems. For example, throwing a coin. So the sample space of throwing a coin will be, it will be a head or it will be a tail. So what will be the probability of head? So head probability will be, and the tail probability will be, so the probability will be 1 by 2 and the probability of 1 by 2. When you add it, when you summation px, let x represent the number of event occur when you throw a coin. So when you add it, 1 by 2 plus 1 by 2, it will be equal to 1. So that is why in the giant probability distribution, when you sum, this is summation for the x, this is the x, and this is summation for the y, because now this is the giant probability distribution. So that is why it will be equal to 1. Now in order to further explain this property, I am just going to discuss a very simple example. Let x and y have the following giant probability distribution. Now this is the giant probability distribution. This you can see, this is in the rows. These values are the x values. These are the random variable x, and these are the values of random variable y. Now, in order to calculate, sometime these properties will be missing. They will only give us the probability that you will get an x, the probability will be 0.40. The probability of getting a 4 will be 0.60. So you can see, and we will denote this probability now not with px, because this is giant probability distribution. So that is why we will denote with gx. So gx is equal to f of x, which is the function of x. When you add 0.0 plus this, it will be equal to 1. Similarly, this is the random variable y. and these are the values of random variable y. So this is the probability of getting 1, let's suppose. For this event, the probability is hy, and we will denote this with hy, and this will basically will be y, this will not be nx. So the probability of getting y is equal to 1 will be 0.25. The probability for the event y is equal to 3 will be 0.50, and the probability for getting 5 for y event, it will be 0.25. So 0.25 plus 0.50 plus 0.25. When you add it, it will once again it will be equal to 1. So the total probability of x is, I already mentioned this simple example in the single probability distribution. So the single probability distribution will always be equal to 1. So the probability of x, the total probability of x will also be equal to, so summation px will always be equal to 1, and summation py will always equal to 1. So normally we denote this for px with represent gx, and for py will be hy. So now the question is, how you will calculate these probabilities? So this is very simple. You will just multiply 0.40 into this one. So when you multiply 0.40, because 0.40 why? Because at x is equal to 2. So at x is equal to 2. So 0.40 multiply by for y is equal to 1. So that is why for x is equal to 2 and y is equal to 1 is 0.25. So 0.25 when you multiply it, it will be equal to 0.10. And this thing is the probability which we get, which is the giant probability when we multiply the total probability for x is equal to 2 and multiply with the probability of y is equal to 1. Similarly, now you can see how you will get this probability. So when x is equal to 4, so when x is equal to 4, so what is the probability when x is equal to 4? Which is 0.60 multiply by for y is equal to 1, which is 0.25. So when you multiply it, you will get this 0.15. Similarly, for x is equal to 2, so for x is equal to 2, the probabilities, the total probability for x is equal to 2 is 0.40. So 0.40, and for y is equal to 3 is 0.50. So 0.50 when you multiply it, you will get this. Similarly, when x is equal to 2, which is 0.40 multiplied by y is equal to 5. So this is 0.25. 0.25. So when you multiply it, you will get 0.10. For this one, when x is equal to 4, so 0.60 multiplied by for y is equal to, so y is equal to 3, this is 3, and the probability is 0.50. So 0.50, which the product of these two probabilities will be 0.30. Similarly, for this one, x is equal to 4, so 0.60 multiplied by y is equal to 5. So when y is equal to 5, 0.25. 0.25. So when you multiply it, this will be the product. So at this way, you will calculate the giant probabilities. Sometime, maybe in exam, maybe in some specific question, these total probabilities for these event will be missing. So what you will do, maybe in that question, these giant probability will be given to you. So how you will calculate this hy? Hy mean the probabilities for these events. What will be the probability of y is equal to 1? So how we will calculate? You need to sum this. So how we will get this 0.25? So you can see this is 0.10, which is equal to 0.10 plus 0.15. 0.15. So this will be equal to 0.25. Similarly, 0.20 plus 0.30. 0.30. So you will get is equal to this. The sum of these two, this and this, will be equal to 0.50. Similarly, for this one, it will be 0.10 plus 0.15, and this will be the sum 0.25. When you add this, the probabilities of y, you will get this one. It will be equal to 1 from this side and also from this side. 0.40 plus 0.60. So at this way, you will calculate the giant probabilities and you will expand it and you will show that this is equal to 1. So now these are the giant probabilities. These are the giant probabilities. Let me show you summation x summation y p x y is equal to 1. So 0.10 plus 0.15 plus 0.20 plus 0.30 plus 0.10 plus 0.15 will be equal to 1. So we already proved this probability, and we already know that probability, joint probabilities, all these probability are greater than or equal to 1. So we already showed this property, and we already showed this probability because these are the joint probability. This is the joint probability of x is equal to 2 and y is equal to 1, which is 0.10, and this is the joint probability when x is equal to 4 and y is equal to 1. So at this way, when we sum all these probabilities, we will get summation, we will get double summation. This summation represent that x, and this summation represent the y value, and this represent the joint probability. It will be equal to 1.